Hey everybody, this is Alex Merced from alexmercedcoder.com, and I want to talk about today is structural design patterns. So in the last video I talked about creational design patterns, which are for creating instances of an object. Structural design patterns are about multiple objects working together and addressing problems with interoperability or just how functions work. So the first one's adapter. So imagine I decide to use two libraries to address some sort of problem or to create my program. Okay, the problem is a lot of the objects in this library were created to function with that library, and the objects in this library were created to function with that library, but they don't really function with each other in a way that's intuitive or makes sense. So basically now you have to learn two libraries for this program to work. Okay, so to make the life for the end user easy, what you do is you create adapter classes. What they do is that you know how they both work, so you create sort of an interface, sort of an object or a method that basically takes the functionalities from both libraries or multiple objects that aren't created to work together initially, and allows them to work together to do things. Okay, so you're creating sort of this adapter. Okay, so kind of like you go to Europe and they have different outlets, so you buy an adapter. So while that outlet was not meant to be used with your plug, and your plug wasn't meant to be used with that outlet, that adapter makes them both work together. So that's what the adapter design pattern is essentially doing. You're creating sort of an interface between the objects. Now the bridge. Okay, so the bridge, the idea here is akin to eliminate redundancy. So imagine that I have a dog and a cat class. Okay, and I wanted to talk about the color of their fur. Okay, whether it is brown or black or yellow. And so what you do is you start creating subclasses. So you start creating a yellow dog, a black cat, and a brown cat, and then a yellow dog, a black dog, and a brown dog. That's 6 classes. Okay, would have made more sense is to create a separate color class with yellow, brown, and black, and then you compare those classes together. So you're creating 2 classes that are separate, so they're not subs of each other, but they can operate with each other. There's a bridge between them. Okay, so you're creating bridge classes that allow you to not have to create so many subclasses. So in this case, I can basically make a yellow dog by combining the yellow class with the dog class. And basically your code base isn't inflating because you're rewriting what yellow is twice for the sake of a yellow dog and a yellow cat. Okay, so that's bridge. Okay, then there is composite. So the idea here is there's things inside things inside things. Okay, so imagine like a very popular data structure, trees. Okay, where you basically have all these nodes, and then when the nodes end, that's a leaf. That's the very end of the branch, where there's no more child nodes. To kind of use a real life example, imagine, I guess the product box thing probably makes most sense. So imagine you get a box from Amazon. Inside that box from Amazon, there's a couple things that you ordered, plus another box. And inside that box, there's some more items you own, and then a smaller box. And then inside that box is maybe one more item that you own. Okay? Now the problem is the box object is separate from these individual product objects. Okay, and what I need to do is figure out, let's say, the cost of all these things combined. So you need to create either like a method or a class that kind of learns how to work with these 2 objects to do things together, especially since they're all embedded in each other. So basically you would have a method that would sit there and say, okay, well, let's open up the box. Are there any products in the box? Let me add up the prices of all those individual items. Oh, there's another box. Let me open up that box, add up the prices of the products there. Oh, there's another box. Let me open that up, and eventually add up all the prices as you keep going deeper and deeper into the multi-layers of boxes. That's essentially what the composite is. It's kind of like how to deal with multiple objects that are embedded in each other in a way that makes sense. Okay, Decorator. Okay, so going back to the dog-cat analogy. So, you know what? Dogs have fur, cats have fur. They both make a sound. okay? And programming that over and over again and you don't necessarily always need fur. There might be an animal without fur, okay? So for example, a naked mole rat. So maybe instead of creating fur, or rewriting what fur is every time I have a class that needs it and doesn't need it, which again, you're inflating your code base because you're rewriting fur, what you can do is you create what's called a decorator. Okay, so this is a very big thing in like TypeScript and whatnot, and in other programming languages. And what a decorator is that you separately create this decorator. So in this case, the decorator would be fur, and basically describes how fur works and the attributes of fur and all this stuff. And then I just plop that in the classes that need it. Okay, so I could have several subclasses of animals. Okay, but they don't all inherit this fur property. So there isn't this property that they inherit of fur or no fur. So then technically they have all that code already, that functionality built into them. When they don't need it, I can just decorate it with fur as needed because the decorator is separate. And I can just plop it where I need it. Okay, which makes everything. So instead of having to have this really complicated parent class that has the possibility of everything, I can create these separate decorators and slap them on the things where they're relevant. Okay. A facade. So let's say you're using a very complicated library in your program. Okay, so this library has all sorts of functionality and you're really only using a small bit of functionality. Okay, and the problem is all that other functionality is just kind of floating around there where your end user might be able to access it, use it, get overwhelmed by it, and you want to make it easier for them. So what you do is you create something sort of in between that maybe uses up less functionality, but makes it easier to use the functionality you do need. In a sense, technically a lot of your frameworks are this, okay? Especially when you think of like front-end frameworks like React, Node, Vue.js, a lot of the functionality that you have in Vue, or Vue, React, and Angular is functionality that's for the most part already native to Node.js. You can do this in Node.js. But there's a lot you can do with Node.js, and maybe you only need these subset of features and you need an easier way to use them. And that's essentially what this provides. So most frameworks are essentially this facade type design pattern. You're creating this way to make use of features or functionality you may already have available to you, but in an easier, more intuitive way, even if it's just a subset of those features. Okay. So again, you're talking about like a complicated library. So then there's the flyweight. Okay, so kind of goes back to the whole fur analogy. Where you do is you try to strip out everything that multiple classes have in common and have them in a separate object. So I might have an object that's called colors that has an array of all the different colors. So that way, instead of having to redefine yellow every time there's a color on an object, they all just refer to the same array. So that way that really I'm making the same reference to the same data item over and over and over again. I'm not taking up more memory. Okay, so I'm not creating, so instead of having this color class where I just keep instancing a new case of yellow every time I want to create a yellow cat, a yellow dog, there's just one instance of yellow, and basically the cats refer to that. Okay, and that is lightweight. What you're trying to do is try to reduce the amount of stuff that's in common. So if you don't have to do it twice, don't do it. So that way your objects are more lightweight and you're using up less memory, because things that are in common are dealt elsewhere. And basically the class itself will only encapsulate the things that are unique to that object. And then there's proxy. Okay, proxy is something where maybe you're using a third-party library, and the third-party library does the thing you want it to do, but the way it does it necessarily isn't the way you want your users to interact with it. So you create an interface with it. Kind of like, let's imagine that a database, and the database is always on, but you don't want the user to always have access to the database, only when they need it. So you create some sort of proxy object. So they're gonna interface to the database object with this proxy object that basically just says, hey, whenever you need it, I'm gonna go over there and query that database or go access that database. I'm not gonna constantly be accessing that database. So the proxy basically kind of like the facade, except the facade with the idea is you have lots of different interoperable objects that you're trying to, put a nice face on. Here we're just saying, hey, I'm creating a proxy sort of a interface with like a singular object to make sure that it functions the way to the end user that I want it to use. But again, the overall idea behind all of these is more with the use of the object. So we're not talking about creating the object anymore, with more the use of the object and how we use it in a way that makes it more usable, solves the problem, manages memory better, all these kinds of things. Those are structural design patterns. So I'll talk to you guys in the next video. We still have one more category of behavioral design patterns still have to do, which talks more about how objects basically how they interact with each other. So now how they work together. So again, here we're talking about how they work. How do we use them to build something? Okay, how do we make these? But a little bit more with sort of how they mutate each other and things like that. We'll get to that when we get to behavioral design patterns. I'll see you guys then. Ciao.